This week, we're going to learn how to take the hover event that shows the water temperature, air temperature, pressure, and station name, and use that to drive a second plot on the same web page. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to take our app from last week that had just one chart and a couple of combo boxes that we could use, and we're going to add a second plot to the layout, and we're going to drive that second plot with events from the first one. This is really great if you want to be able to use, say, the lasso tool and select some data on one plot and just see that data highlighted on another, or do something with that data, like plot it against each other on a separate plot. But in this case, we're just going to use the hover event and use that to actually pull down new data. So what I want to do is when I hover over a station, I want to go pull the time series for that station and display it on another plot beside this one. Now for this week, we're going to keep it relatively simple and just have one plot that's driven by this, but we're going to look at how we can build something more like a full mediogram. All right, so what we need first is a function that's going to create this second plot. So I'm going to call it update time series. And it is going to take hover data, event from the mouse hover event. Now, if you look at what you get from a hover event in the documentation, we're going to get points. So a list of points, and in that list of points, there's going to be a dictionary that contains properties. In our case, we're interested in the hover text. We know that when we hover over a point, we get the station name and some other metadata that we put in there. All right, so the station name is going to be our hover data, the points part of that dictionary. We're just going to be hovering over one point. We don't want to get data for multiple stations. So we're just going to get the first thing that we're hovering over. And then from that dictionary, we're going to get the hover text key. And that's going to contain our station name. Now we need to go get the data from the NDBC for that station. Remember, we had called the latest data series in our other plot, but now we want to get the observations for all time series for a given station. And for that, we use the real-time observations method. So the data frame that we'll get back from that is going to be from ndbc.realtime observations, and that's going to take our station name. And for now, we're just going to do one plot, as I mentioned. So we're going to create a figure, px.scatter, the data frame, the x variable is the time data series, the y variable. Let's stick with the pressure data series for now. We're going to use that fig.update layout, again, just to animate, make things look nice. And then we're going to return the fig object. So going to our app for just a moment and looking at it, how do I want this to look? I think I want this scatter plot to be a small plot off to the left, and I want our larger time series plot off here to the right side. So we need to change our layout by adding some divs to accomplish this. So going down here into the layout attribute of our app, we scroll down to the bottom, and we see here we have one simple div that has our buoy correlations graph in it. We know what we're going to need to do is put that itself in a div. So html.div. We're going to indent so that's a little easier to see what's going on here, and we're going to close that div. So now we've got our buoy correlations plot in a div. html.div and we need to put a comma here separating these. We're going to again create another div for our new plot. And the ID for this one is going to be buoy time series. All right, and let's go ahead and indent that. So now we've got our each plot in a div, so these are going to be stacked, but let's start there. So now we've got two plots, but we haven't yet hooked up any kind of logic to our function update time series. Now the reason that I wanted to come back to this is I wanted to go ahead and assign our ID down here so we knew what we needed to use in that callback decorator. Remember, our decorator is app.callback. And in the callback decorator, we use inputs and outputs. So what is the output of our callback going to be? It is going to be the ID buoy time series. And that buoy time series is a figure. What about the input? This is where it's a little bit different. We still have an ID, and our ID is buoy correlations, because that's the figure that we want to look at. But now we're looking at the hover data attribute. So whenever hover data and buoy correlations changes, this callback will get triggered, and it will replot buoy time series as a figure with whatever this function returns. Okay, so we've got our callback hooked up. Let's go ahead and save and see what our app does. So looking in our app, interestingly enough, we do have a second plot, but we have an error. And our error says that none type is not subscriptable. So we're trying to access the 0th element of something that is a none. So why would that be a none? Well, we haven't hovered over anything yet. If I hover over something, we get a plot. So there's our time series plot of pressure. If I hover over another station, that time series plot of pressure updates. So the app's working, but when the app first loads, it doesn't know what we're wanting to plot down there because we haven't yet hovered over anything. So let's go ahead and fix that up. Back here in the code, we're going to go down into our layout. And for our graph buoy correlations, we're going to set hover data to be a dictionary. Remember, points is the key that we're looking for. And then in the value of that, we expect a list because we're getting the 0th thing. And in that list, the 0th thing is a dictionary. And we're looking for the hover text key. And the value of that key is going to be a station name. So I just picked a random station, AST03. And now we have a default setting when this loads, but then when I do my hover action, that's going to change. So let's save and see what our app does now. All right, so reloading our app. Here's AST03. And now if I hover over a different station, we see that that changes. But this is not a very convenient user interface for sure. I have to scroll back and forth to see these plots. So let's go ahead and work on our app layout a little. What we're going to do is change the width of these divs, which we've done before. So after we close out all of our information that's in the div, we're going to set its style properties again. So style, remember, is a dictionary. I'm going to set the width to be 35%. Now I'm going to add another div to put a little bit of space between my two plots that has no content. Style, I'm going to set width to be something like 5%. Don't forget our comma. And then our last div that has the time series plot, we're going to set the width to be 60%. We want that to take up most of our screen. And then for the div that contains these two plots, we need to set the style attribute, remember, to say we want this to be a flex display, preferably in the row direction. So I'm going to set display to be flex, and I'm going to set the flex direction to be row. All right, so now we've got two divs in a div that has a flex specified. Let's see what our app looks like. All right, this is basically what I had envisioned. So I've got my plot over here, and if I wanted to look at the pressure tendencies or mediogram, once we get that plot on the right fixed up even more, for a station with the highest water temperature, there it is. And in fact, that's a very noisy signal. If I wanted to see a station with the lowest water temperature, there that signal is. So we can scroll through here and look for any kind of tendencies. If I wanted to plot, let's say, the station latitude, we could look at air pressures in the mid-latitudes versus air pressures in the higher latitudes. So this is an easy way to make two graphs interact with each other in a web app with really not that much code. So next week, we'll look at how we can do some more complex matplotlib style graph manipulation to really finish this app up and make it a powerful data exploration tool. I hope that you found this useful, and I'll see you on next week's MetPy Monday.